Okay, up next we have factoring quadratics, and actually the first couple we're going to look at might not necessarily be a quadratic, but it's just some patterns we can use. Usually we're going to see quadratics for what we're doing right now, right? So our first thing that we're going to talk about is what a quadratic is. So a quadratic is what we call a second degree polynomial, and it's characterized by having an x squared in the equation. All right, so as long as you have a 2 as your highest exponent, that's going to make it a quadratic. Okay, standard form for a quadratic is y equals ax squared plus bx plus c. Right, and the a, b, and c will come in handy in a little bit, but standard form just means that you have the x squared first, then your x term, then your constant. So you go in descending order for your exponents. All right, so we have 4 ways that we're going to look at. All right, the first one is what you should always look for, whether it's a quadratic or not, whether you have 2 terms or 15 terms, always look for the GCF. Sometimes something can look super challenging until you look for that GCF, and then taking out the GCF makes it so much easier. So GCF stands for greatest common factor. So I'm looking for the biggest number or term that goes into all of the terms of that polynomial. So for the first one, 9x plus 36, right? My hint to you is always start with the bottom number. I'm going to start with, or the smallest number. I'm going to start with 9. Okay, 9 goes into itself, but 9 also goes into 36 4 times. So 9 is going to be part of my GCF. So I'm going to take a 9 out. Now, there's an x here, but there's not an x here. So they don't both have variables, so I can't take out a variable. They don't have one in common. So I'm just going to take out a 9. Once you find your GCF, to take it out, you divide by that GCF. So 9x divided by 9 is just x, or 1x, right? 36 divided by 9 is 4, and keep that sign. So we get 9 times x plus 4. That's my factored form when I factor out my GCF. Okay, now you can always check your work. If I wanted to move backwards, okay, factoring is the opposite of multiplying, right? So factors of 6 are 2 and 3 because 2 times 3 gives you 6. So factors of 9x plus 36 is 9 and x plus 4 because 9 times x plus 4 should give me 9x plus 36, and you can test that by distributing that 9. 9 times x is 9x, and then 9 times 4 is 36. So we got the right factors. Okay, for the next one, okay, again, start with the smallest one, right? It might not always be the smallest number, but you can start there and work your way down because it can't be bigger than your smallest number. All right, so I'm going to start with 3, and 3 goes into itself, and it goes into 6. So I'm going to take out a 3 as my GCF. But this time, both of these terms have variables. So if you're picking the GCF to take out in terms of your variables, take the variable with the smallest exponent. So I'm going to take out that x cubed because this means that this guy's got 3 x's and this guy's got 5. So they both have at least 3. So I'm going to take out the x cubed, right? 6 divided by 3 is 2. I had 3 x's, but I took 3 out, so I don't have any x's left in that first term. Negative 3 divided by 3 is a negative 1. So I'm just going to, I don't have to write the 1 if I have a variable there. I had 5 x's, I took 3 out. So that leaves me with 2. All right. Another thing you can do to double check and make sure that you're on the right track. If I have terms left inside my parentheses, if I took the correct GCF out, those terms aren't going to have anything left in common. So you see I have a 2 and a 1, so they have nothing in common. They're both prime. And then I have no variable and a variable. So they have nothing left in common. That tells you that you took out the correct GCF. All right, for the next one, I'm going to start with my smallest number, but 14 does not go into 21. So that means 14 is not my GCF. It's got to be smaller than 14. So the next biggest number that goes into 14 is 7. So 7 times 2 is 14, and then 7 times 3 is 21. So 7 goes into all of these terms. Okay, so I'm going to take out a 7. And they all have variables. So I'm going to take out the smallest exponent for my variables. And that's going to be this x to the first power. That's my smallest one. So I'm going to take out a 7x. So 14 divided by 7 is 2. I had an x, but I took one out, so I don't have an x left with that term. 21 divided by 7 is 3. I had 2 x's. I took one out, so that leaves me with 1x. 21 divided by 7 is 3. So I had 3 x's. I took one out. And there's my factored form when I take out my GCF. Okay, one more. All right, I'm starting with the smallest number, which is that 8. 8 does go into 24, but it does not go into 12, so I have to get smaller than 8. So the next biggest number that goes into 8 is 4. 4 goes into 8, 4 goes into 24, and 4 goes into 12. All right, so I'm going to take out a 4. Now, this one's a little bit different. I have a negative out front. So far, we've only had positives out front. Your GCF keeps the same sign as whatever's out in front. So for the first 3, I had positives out in front, so my GCF was a positive. But here, because I have a negative out front, my GCF is going to be negative. All right. Then I have x's in all terms, so I'm going to take the smallest exponent, and that's going to be the x to the 5th. So my GCF is negative 4x to the 5th. Now, when you take out that negative, it's going to change your signs, because a negative 8 divided by negative 4 is a positive 2. All right, I had 7 x's, but I took 5 out, so that leaves me with 2. 24 divided by negative 4 is a negative 6. I had 6 x's, but I took 5 out, so I have 1 left. 12 divided by negative 4 is a negative 3. And then I had 5 x's, but I took all 5 out, so I don't have anything left there. All right, and we can double check. 2, 6, and 3 don't all have something in common, right? So yes, 2 and 6 share something, and then 6 and 3 share something, but 2, 6, and 3 don't all have something in common, so we don't have any other GCFs. All right, difference of squares is another pattern, okay? And difference talks about subtraction, right? So you have to have subtraction, all right? Squares is talking about perfect squares. So a perfect square is like 16, because 16 equals 4 squared, right? So your perfect squares are the ones where when you take the square root, you get a nice pretty number, all right? And then the pattern is just one you have to memorize. So this looks a little weird, but if I have something squared, that makes it a perfect squared, minus something squared, then once you find your square roots, you just plug them into a plus b, a minus b. All right, so for the first one, I have subtraction, right? Actually, for all of these, I have subtraction. So I have the difference part, and I have to look for the squares. So x squared is a perfect squared because it is x squared. So the square root of x squared is x. The square root of 1 is 1. And we plug it in. You have x plus 1, x minus 1. Okay, now order doesn't matter in terms of the plus or minus. I could do x minus 1 times x plus 1, that's fine. Or you could keep it this way, x plus 1, x minus 1. But the x does have to come first before the 1, so keep that in mind. All right, for number 2, the square root of 9x squared, think about it separately. The square root of 9 is 3. The square root of x squared is x. Square root of 4 is 2. So I have a 3x plus 2 and a 3x minus 2. All right, for number 3, all right, the square root of 16 is 4. Square root of x squared is x. Square root of 49 is 7. Square root of y squared is y. All right, so then we have a 4x plus 7y. And a 4x minus 7y. All right, now number 4 messes us up because 2 is not a perfect square and neither is 8. But there's something we're always supposed to look for first, and that is a GCF. So I do have a GCF here. Start with that smallest number. 2 goes into itself and into 8. All right, so that means I'm going to take out a 2. All right, 2 divided by 2 is 1, so I'm left with just the x squared, and then negative 8 divided by 2 is a negative 4. Now I have difference of squares. So the square root of x squared is x, 4 is 2, so that part becomes x plus 2, x minus 2, but that's not my final answer. You can't forget that guy. That 2 is a factor. That's part of your final answer. You got to make sure it comes all the way down to the end. All right, and then the last one of these this x to the fourth looks kind of weird. You know, or you can know, that a variable is a perfect squared as long as you have an even exponent. And then to find the square root, you cut it in half. So for example, if I had x to the 10th, the square root would be x to the 5th. Right? So as long as it's even, you know it's a perfect square. So this one's even, it's a perfect square. Half of 4 is 2. So my square root's going to be x squared. And then 16 becomes 4. So we've got x squared plus 4 and x squared minus 4. Now this one's different. I didn't get down to a variable to the first power like I did for all the other ones. So we've got to double check and make sure we can't factor it again. So here I have x squared, which is a perfect squared, and I have 4. But it's adding. So this is the sum of squares, and we don't have a pattern for that. So this part I cannot simplify. But over here, I have that difference. So the square root of x squared, come up here, is x, and 4 is 2. So this parentheses can break down to x plus 2, x minus 2. But don't forget about this guy. That x squared plus 4 is still a factor. I just can't break it down anymore. So with difference of squares especially, make sure you can't keep going. Make sure you can't factor it again. All right, the last two patterns we're going to look at are trinomials, and we have two kinds. The first one is what I call plain Jane, right? And that's not a very formal name. That's just something that I call it because it's a one-step factoring problem if it's factorable. Okay, so remember, standard form was this ax squared plus bx plus c, where a is the coefficient for the first term, b is the coefficient for the second, and c is your constant. Plain Jane is when a equals 1. So like this first example here, I have a 1x squared. So if it's a plain Jane trinomial, I can go straight to my two parentheses and I can put an x in them every time. All right, then I have to find two numbers. Okay, so you're looking for two numbers that are going to multiply to get the c term, right, your constant, and add to get the b term. So we're going to multiply to c, add to b. So in this case, my c is 6, so I want to multiply to 6, but add to 5. So my factors of 6, I'll do them in a different color. You have 1 and 6, or 2 and 3. Those are my only options. Well, 1 plus 6 is 7. 2 plus 3 is 5. So 2 plus 3 is the ones I want. So I have a positive 2 and a positive 3. Done. All right, the next one, plain Jane. So I'm going to go straight to my parentheses. But now I want to multiply to a 12 and add to a negative 7. So my factors of 12, we have 1 and 12, 2 and 6, 3 and 4. But there's no way that I can add these together to get a negative 7. So you got to remember, if you have a positive c term and a negative b term, you're going to have two negative numbers, right? Because negative 1 times negative 12 is also positive 12, right? So if I have two negatives, right, I can multiply to get that positive. And the only way I can add to a negative number with the same sign is if I have both negatives. So that means this one's going to be minus 3 and minus 4. Okay, for number 3, I'm going to add my parentheses here. All right, now I've got multiply to the 8 and get to the 2. So my factors of 8 are 1 and 8, 2 and 4. All right, now I want to multiply to a negative number. That means I have to have one positive and one negative. So I could have negative 1 positive 8 or 1 negative 8. Negative 2 positive 4 or 2 negative 4. All right, and the one that's going to add to give me that negative 2 is a 2 and negative 4. So a plus 2 and a minus 4. And again, order doesn't matter with which parentheses you put first. Okay. Now another way of thinking about it, if you can quickly figure out that when you multiply to 8 and you can somehow get to 2, the bigger number always keeps the sign that's in the middle. Right? So if I could figure out that it had to be 2 and 4, 4 has to keep the minus sign because that's what's in the middle. Okay, and then for number 4, oh no, it does not look like it's plain Jane. But the first thing we're always supposed to look for, GCF. So I'm going to start with this bottom number, and 2 goes into everything. So I'm going to take that 2 out. The 20 doesn't have an x, so I can't take any x's out. So I'm just going to divide everything by 2. That's going to give me x squared plus 9x minus 10. Now I can factor plain Jane. All right, so I'm going to put my parentheses with an x in them. And I want to multiply to a negative 10, but add to a 9. All right, now I talked about how the bigger number keeps a sign in the middle. So a way of looking at it is if I said, okay, my factors of 10 are 1 and 10, 2 and 5. Because I'm multiplying to a negative, I want two numbers that have a difference of 9. And that's going to be my 1 and 10. Okay, so I could put a 1 and a 10 in there. But the bigger number keeps a sign that's in the middle. All right, so if I have a negative C value, I'm looking for numbers that have a difference of that middle term. If I have a positive C value, they have to add to get that term, and it's just a matter of your positives and negatives. All right, bottoms up, okay, is if A is not equal to 1. Right, so that's where it gets a little more complicated. It's not as quick as going straight to my parentheses and figuring out the numbers. Right, so the steps for bottoms up. The first thing we're going to do, right, this 3 here is what's messing up this equation, right? Because if I have an A there, right, that A, that's not 1, that's what messes it up and makes it where I can't do what we did for plain Jane. So what we're going to do is move that A. Right, so step 1 is to multiply A. All right, and we'll start doing this one. And I'm going to multiply and make it part of C. Just for a minute. Just getting rid of it for a minute, but I'm not taking it out completely. I'm just moving it to a different part of my equation. So then I'm going to have x squared minus 2x minus 15. I did 3 times 5. All right, now it's plain Jane. So this I can factor. So step 2 is to factor the plain Jane trinomial like we just did. So I want to multiply to negative 15, but add to negative 2. So I want to multiply to a negative. That means I want the difference to be 2. So that's 5 and 3. Bigger number keeps a sign in the middle. All right. But this is not factored form. This is the factored form for that second line there, not the first one. So the first thing I did was move the A by multiplying. Well, now I got to take that A back out. And the opposite of multiplying is dividing. So I'm going to divide by A. So my original A was 3, so I'm going to take these two numbers and divide by 3. All right, simplify. I can't simplify 5 over 3. All right, 3 over 3 is 1. So I have x plus 1. All right, and then the last step, the reason that we call it bottoms up. Okay, we don't want to leave a fraction in our factored form. So if you have a fraction, and if you're doing this, you should always have at least one fraction. So if I have a fraction, I'm going to take whatever is on the bottom and move it up in the front of that parentheses. So instead of having x minus 5 over 3, we're going to have 3x minus 5. And there's my factored form. Okay, now if you like doing the butterfly or the cross or whatever x method, that's perfectly fine. This is just what I think is easiest, so this is what I teach, but as long as you can factor, you can get the job done. I don't care how you get there. All right, for the second one, I'm going to start by getting rid of that 2. And so that's going to be 5 times 2, which is 10. Then I want to factor, plain Jane, so I want to multiply to 10, but add to 11. That's going to be 10 and 1. Okay, then I got to take that A back out. So we divide by 2. Simplify. 10 divided by 2 is 5. All right, and then I can't simplify 1 over 2, so I'll leave it. And then I have one fraction to take care of, so I'm going to move that fraction, or the bottom, out front. So I have x plus 5, and then a 2x plus 1. All right, and then for number 3, okay, remember, look for the GCF first, because if you don't take out the GCF, you won't get to the completely factored form. All right, so the first thing I'm going to do is take out a GCF here because they're all even, so I know at least 2 goes into all of them. So I'm going to take out a 2. Now remember, that 2 is part of my final answer. We can't forget about that 2. All right, but 12 divided by 2 is 6, 10 divided by 2 is 5, and then 12 divided by 2 is 6. So now I'm going to do bottoms up. So I'm going to take my A, move it over here. Now I'm going to ignore the 2 for a minute, but I can't forget about him at the end. He's got to be part of my final answer. So x squared plus 5x minus 36. So I want to multiply to a negative 36, but add to 5. That's going to be a positive 9 and a negative 4. Then I got to take that a back out. So I'm going to divide these by 6 and simplify. Okay, now 6 doesn't go into either one of those, but I can simplify my fraction. So 9 over 6 is going to become 3 over 2, and 4 over 6 becomes 2 over 3. And then anytime you have a fraction, it's okay that both of them are fractions, we're just going to move it to the front. So I have 2x plus 3 and 3x minus 2. And don't forget this guy. That 2 has to go out front. If you take out a GCF, it's got to follow you all the way down to get to your final answer. Okay, so factoring quadratics is important because it's also a way that we can solve, that we can solve a quadratic, right? So if I want to solve by factoring, the first thing we got to do is always set it equal to 0, right? You want to get everything on one side. So for this first one, I'm going to start by subtracting the 6x over. So I have 3x squared minus 6x equals 0. All right, so then I'm going to factor. Now here, it's not a trinomial, so I'm not going to do plain Jane or bottoms up, so it's either going to be GCF or difference of squares or both. So I'm going to start with a GCF. So I'll start with my 3. 3 goes into itself and 6, so I'm going to take out that 3. And then they both have an x, so I'm going to take an x out because that's the smallest exponent. So 3 divided by 3 is 1. I had 2 x's, I took 1 out, so that leaves me with 1x. Negative 6 divided by 3 is a negative 2, right? And then I took the x out. Okay, so now when it comes to solving by factoring, the reason we set it equal to 0 is because we have something called a zero product property, right? And that lets us solve because the only way I can multiply and get to 0 is if one of my numbers or one of my factors is 0, which means the 3x can be 0 and the x minus 2 can be 0 because I have something times something to get me to 0. So what we do to actually solve is we take everything and set it equal to 0. Let me change colors here. So I'm going to say 3x equals 0 and then x minus 2 equals 0. Right? To solve for x here, I divide by 3, and 0 divided by anything is still 0. And then here I add 2, so we get x equals 2. So my solutions are 0 and 2. Okay? For the second one, all right, I got to set it equal to 0 first. I'm going to subtract the 15 over. So we get x squared plus 2x minus 15 equals 0. Well, this one's plain Jane. So I'm going to go straight to my parentheses. I want to multiply to a negative 15, but add the 2, so that's going to be a negative 5, positive 3. Okay? Then I want to solve. So I'm going to take each of those. Anything that has an x, I'm going to set equal to 0 because I want to figure out what x is. Add the 5, so I get x equals positive 5. Subtract the 3, x equals negative 3. And those are my solutions. Right? And then for the third one, we got to do some bottoms up. There's no GCF. 3, 8, and 4 don't all have something in common. So I'm going to start by getting rid of that 3 for a minute. Then it's plain Jane. Right? I want to multiply 12, but add to negative 8. That's going to be a negative 6 and negative 2. And then I got to divide by my 3. So 6 divided by 3 is 2. Right? Can't simplify 2 over 3, so we'll do bottoms up. So we get x minus 2 times 3x minus 2. All right, and that equals 0. Same as before. Okay, and I'm going to come over to the side, leave some room down there. So I can say x minus 2 equals 0, so x equals 2. And then 3x minus 2 equals 0. It's just a two-step problem, not quite as easy. Start by adding the 2. So 3x equals 2, and then divide by 3. So x equals 2/3. So we get 2/3, and we get 2. When you solve quadratics, you can have no solution, one solution, or two solutions. So keep that in mind. All right, now this factored form is also what we call intercept form. So we talked about standard form in the beginning, that ax squared plus bx plus c. Intercept form is factored form, and it looks a little weird. Adding some new letters in there. And it's a times x minus p times x minus q. Okay, A is the same A that's in standard form, right? The P and the Q are your x-intercepts. All right, and then one last thing. Okay, these x-intercepts, right? Notice that it's the opposite sign here. Just like it was when I had x plus 3 in my parentheses, that became a negative 3, right? So if I have x minus p, that becomes a positive p. So these x-intercepts are also my solutions. Okay, there's 4 words that mean the same thing, right? And then sometimes they throw you off, but if you know that they all mean the same thing, you won't get thrown off when they ask you a question. Okay, so 4 words that mean the same thing. Solution, root, 0, and x-intercept. So if it's asking you to find the x-intercept and it doesn't give you a graph, you can factor and solve it and it'll tell you your x-intercept, right? Or if it's asking you for a root, you can look at the graph and see where it crosses the x-axis. They all mean the exact same